All right, to anybody just joining us, thank you for stopping by, and we will wait for some questions to pop up here. So in the meantime, while I'm waiting here, I guess I will just pull up some random math questions for us to crunch through. So let's see. Let's find a good question here. So I'm looking at an old book, and I prefer to do something that doesn't require a calculator. Tangent lines, can do those. Okay, so it says we have let's see. Finding a good question here. Don't quite know which one I want to do yet. All right, how about an inverse question? So we've got f of x equals x to the third. So make that neater. Plus x. And then we're going to have h of x is equal to f inverse of x. And let's say we want to find h prime of 2. So what is this equal to? Now, for this one, the idea is that h prime of 2 is really going to be the derivative of f inverse. And just know this formula. F inverse prime of x is equal to, we have 1 over f prime f inverse of x. So at some point I need to know what is f inverse of 2. So if I want to know what is f inverse of 2 equal to, well, I should look for when is the function f of x, when is this equal to 2? So for which value of x is this going to be true? So when is f of x equal to 2? And honestly, for this, what you need to do is you just set x to the third plus x equal to 2. And here, the value that's jumping out is x equals 1. So this is a value that we're going to need here. And if we go forward with this, that tells us since f of 1 is equal to 2, f inverse of 2 is equal to 1. And then what we could also find is f prime of x. F prime of x is 3x squared plus 1. So then to evaluate this derivative, what is h prime of 2? H prime of 2 is equal to the derivative of f inverse at x equals 2. So this is 1 over f prime f inverse of 2. And this is going to be 1 over f prime. F inverse of 2 is equal to 1. And if we plug in here, plug in 1 to the derivative, you get 3 times 1 plus 1, which is 4. So this one is looking like 1/4. Okay, so just a warm-up question here, but it looks like we have people now. So hello to anybody here. And as always, if you have questions, please, you could type them in the chat or you could email them to vinteachesmath@gmail.com. And I'm happy to answer your questions. But right now we have just 2 people, but I'm 2 people. Hello. Thanks for being here. Oh, hello. How you doing, Psycho Slayer? Thanks for being one of the regular visitors here. I appreciate the continued support. Just another fun-filled week. Tiring week. I would definitely say a lot of stuff going on. We got report card grades due. Letters of recommendation are due. So it's definitely been a busy few days. So definitely looking forward to whenever the next day off is. I could definitely use a day off. But the live streams are in a way like very refreshing because it's something that's not like I don't know, in a way it doesn't feel like a job because this is let's see, I need to do this to make up for not taking BC and UDORP. Oh yeah, that's quite all right. You have the luxury of time on your side, recent graduate, that you got all the time in the world to learn some math. I dug up an old book. Now, oh, here it is. So this is actually my Calculus 3 textbook. So let me just see how this is going to look. Yeah, this one here. It might be flipped backwards, but my Calc 3 textbook. So my plan is when the AP test is over and the school year calms down quite a bit, what I will do when the live stream, actually I should retract that. After the math regents in the summer, in June, after algebra, geometry, algebra 2 is done, my plan is to make, first I'm going to do, I want to relearn Calculus 3. Oh, yeah. No, definitely. Violins here. Yeah, it's because it looks like the integral. So, this is my original textbook. And you can see here the sticker that, the green screen is kind of chopping. Oh, you know why? Because the green sticker and the green screen is going to chop that out. But this is from a place called Mando Books in Vestal, New York, which is where SUNY Binghamton is from. Kenny, what's up? So I was just saying here how after the Regents, I'm going to relearn, because July is always a very slow month. So I'm going to just relearn Calculus 3 over the summer. And I'm going to do it live. And then, because my goal is, and you all inspired me for this, by the way. Like Kenny, I think you and maybe a few others went right to Calculus 3. That I'm inspired to learn Calculus 3, relearn it, because I would be so cool, when you were all done with BC, if you come by the live stream and I could actually still help you with math. Because I feel bad that that Calculus 3 I haven't taken since 2009, so it's gone. But it would be cool to, be able to stay in the loop. And oh, okay. So yeah, Kenny, you know what? You're in a unique spot that because you learned Calc BC so well, that I think you're gonna have an advantage with understanding the concepts. Because when I took Calc 3, I didn't ace Calc 1 and 2. I was not really as focused as I could have been. So that's why I want to relearn it now with my, now I'm way more focused. That, I mean, if I would have relearned it at the end of college, I probably should have, but I was so focused on the other classes, with, the math classes that we're taking was very much proof based. So we kind of strayed away from the calculus, kind of. So, but I do want to go back to it for sure. I think it's great. Double integrals, and they have triple integrals. There's line integrals. There's something called Green's theorem. Yeah, there was some wacky stuff in Calc 3. I was decent at it. I mean, I think I got a B plus in Calc 3. I would have been in the A range, but it was my fault. You always got to own it when you mess up. It was my fault because the quizzes were early in the morning. And I remember I was kind of lazy about my quizzes being at 8:30 in the morning, that I like to study before. And because it was so early, I never woke up in time to study before. So I just kind of showed up and just kind of winged it every time on quiz day. And so B plus. My quiz average was a D in Calc 3. So my test scores were A minus, A range, at times. They were pretty decent. But the quizzes just crushed me every week. Because you had a quiz every week. I was just tired, unprepared. So, it was my fault. My work ethic was not what it was, what it is now. So, but that's so cool that you're really in the heart of these classes. So that's great. You're gonna do very well. So just it'd be cool to see where you land and stuff. So we got 4 concurrent viewers. I could throw another math question in here. Sounds like your AB class. Yeah, I mean, I would say the key is that you just like you could mess up, but you got to like try to learn from it, and like try to upgrade every semester. I wasn't like I would say I got really motivated by like junior senior year of college, and then I was a super senior at college. But that's when like I really got like serious about studying, where I was like living in the library. Like that's when I would say I got like pretty decent at math, was like those years. In the beginning, I was just kind of relying on like natural ability. Like I was getting by, but I wasn't like crushing anything. Like I was just like, like this is like the best I'm willing to do. And I had smart friends around me, like in the beginning also, and they would like help me a little bit here and there, and like that was enough to get by. But like they would like coach me, like tutor me a little bit on stuff. But when I really went all in is when for sure like my grades went up. So there's something very nice about going all in. Like when you make that call to like, all right, like here we go, let's do this, and let's commit, let's get really good at one thing. That's definitely what we should be aiming for sure. But it takes time to hit that level. So hello to anybody that's here. So we got 5 people on the stream right now, I think it says, and 12 people swung by total. So thank you to everyone who... Oh, let's see. Said you got a B on your recent calc test, but teacher only enters... You know what I should get set up here? Maybe I will... Could be like me, Kenny. You're gonna. I always say like the students in my BC class. I think you're all gonna go further. For sure. Farther. Gonna go farther than me. Further your understanding, but you go farther out. Somebody commented on one of my YouTube videos. They kind of like ripped me for my choice of words in one of my videos from like 8 years ago, and they're like, "How about you read up on the difference between further and farther?" And I was like, thanks, man. Thank you for being so... I mean, people are just brutally honest on YouTube. Watch any interesting movies? So let me just see. I could switch to Q&A mode real quick. Let's see. Is my fireplace still good? Oh, my fireplace is still great. Let me pop the chat out, because I think if I pop the chat out, then we'll just go to Q&A mode. Let me see here. If I expand this... There's going to be some behind the scenes editing here. Let's see. Q&A, window capture. I will switch to... Oh, all right. Here it is. All right. You're all going to see like some behind the scenes stuff real quick. Oh, wait. The chroma key is already just added in. That's cool. But let's see here. All right. So I'll talk... we'll just take comments here for a moment, but let's see. Let me extend this out. There we go. All right. So at Marin Elise, let me just see here. For one, sorry if you're sad about your grade. A B on a test. Your teacher only enters test grades. So you have no homework and classwork for your semester grade. That is like pretty intense. Now, I know my school is like 40% class participation, so they definitely have like a little bit of help if they have like lower test scores. But college is like basically for the most part like all either homeworks or like test and quizzes. There's no like class participation, classwork grade from what I remember. Like at least when I took it, it was like 20% test 1, 20% test 2, 20% test 3, and then it was like the other part was like the midterm or the final. Like, so I'm just resizing this here so it's not like my whole face and stuff. So I would say it's hard to get over this because most of the kids who take AP Calculus are like, you're like the motivated bunch of the school. I know the school. I can't talk too much about my school and the current students. Like it's, definitely like there's like those kind of like the HIPAA laws of teaching, like keeping their academics confidential. But what I can say is that like AP students, like usually, like in like most cases, are like the top performing kids at the school. So it's great that you really care about your grade and stuff. But as hard as this may sound, I would say, like, unless you're going to like med school or something, like it's okay if you don't graduate with a 4.0 or close to a 4.0. That it's more about like the experience and leveling up, you know. And the biggest difference between an AP class and a regular high school math class is that now you're starting to see what the math is in like the big leagues, you know, where they're going to hold you to like really like high standards when they grade you. They're going to be very honest when they grade you. So that's just something that, you know, it's better to feel that a little bit now than to just go into college and then your first semester is just like, whoa, what on earth just happened? But I feel your pain. Like I made a video like somewhat recently about like not doing well, like my worst math test experience. So, you know, I could relate. I know it sucks when you get a bad score or a score like, you know, B is not bad, but like if you're like, oh, I want A's, then like I feel your pain. It's not easy to get over. But you know, you just keep at it. You keep going, keep practicing. If you keep at it and you keep practicing, like you could totally get the high score on the AP test, because the AP test is like the final prize, you know. Like if you do well on that, then you get the college credit. So it's yeah, I hope you know, doing okay. But interesting movies lately. Let me think. What have I watched? I don't know. Did I watch anything cool? I feel like I'm so I don't want to say boring now, but like with two kids, in my free time I'm doing YouTube stuff and other stuff. But the most recent movie I watched, I probably watched Star Wars again. I mean, I'm wearing a Star Wars shirt right now, so I'm a pretty big Star Wars fan. You know what it is like when you get older? It's I would say like your TV experience, like you really want to like for some reason, like when I watch Star Wars, it's like it just reminds me of like 20 years ago, let's say, and it makes me happy. So that's like something I could always go back to, and it like I can remember like people I've watched the movie with, so it like makes it extra special. It kind of like ages, like it gets better with time. Some movies, but I want to definitely like venture out and watch more stuff. I don't know what I'm looking forward to recently. It seems like the movie experience itself is like, I wouldn't call us like that we're necessarily in a golden age of movies, because it's more about TV shows these days. Like TV shows just seem to be more popular. I think Matt Damon even said it too. He was like, yeah, like movies today, it's just not as profitable because no one's selling DVDs anymore. DVDs used to be like a massive part of our revenue. So I don't know, like the streaming services are totally changing the game for movies. But I do appreciate a good movie though, for sure. Like I do enjoy movies. These days I like comedy and like Star Wars type films, because like, you know, if you're gonna like unwind, I just want to laugh and relax. All right, let's see. Other comments. Hello to everybody. So good after it's definitely afternoon. Hello. Let's see. Hi. So hello to everybody joining in. Oh, let's see. So Kenny, you're saying here that you're 25% midterm 2, final. Oh, and homework. Okay. That's a pretty realistic spread. So, yeah, to any of my current students, if you don't know Kenny yet, Kenny was one of my students from last year that got a 5 on his BC test. So, if you want to ask Kenny, if you don't mind answering their questions, you know, there's, if anyone's got like how to get a 5 questions, I would say Kenny is your guy. Because you were like on point the whole school year last year. You did not flinch. Like you were like spot on the whole year. So awesome work. All right, let's see. It better not. Oh, from the new trilogy. You're talking about 7, 8, 9, or are you talking about 1, 2, 3? Which one would you consider the new trilogy? So you think 7, 8, 9 it ruined Star Wars? I don't know. I could talk Star Wars for like 10 hours if need be. But which new ones are we talking about here? Just so I maybe get. So I'll wait on that one. But I'll rewatch them like kind of in order. But my favorite ones are 4, 5, and 6. I would say episode 5 is my favorite. There's like the most happens in episode 5. So let's see. Stand and Deliver. Yeah, no, that movie is definitely very cool. I mean, if it was if it was that memorable, like I'm glad, Kenny, that it was like an inspiration, because it's totally cool. Is MVC supposed to be easier than BC? Multivariable calculus, I'm gonna guess. That depends. Some people have said, like, I don't know, there's like this kind of like one of those like urban legends, like, oh, Calc 3 is easier than Calc 2. I would say what makes Calc 2 like terrifying for people is sequences and series, like the Taylor-Maclaurin series. But that depends on you. For my students, like, it's kind of like hit or miss. Some kids are like, whoa, this is the worst thing I've ever seen in my life. Other ones are like, I practice. It's not terrible, but just practice and you'll get good at it. So I would say that's why multivariable calculus to some people is considered to be easier than BC, because BC, you have to be really good at Maclaurin and Taylor series and Taylor polynomials and all sorts of other stuff. You're doing UI, UCs. Oh, okay, very nice. I'm glad you're going heavy with the math. So that's I'm always happy to hear that people are going heavy at it. Oh yeah, 1 through 6, nothing past Return of the Jedi. Yeah, there's a whole lot of memes on the 7, 8, 9. I mean, I'll watch 7, 8, 9, like just to get a feel. But I think because I watched the movies with my wife, and she was a math and English major. She's like really good at like breaking down plots and like talking about like the storyline and like what makes it like a really awesome story or a weak one. So I got to quote her on this, because like that's not my analysis. It was like totally her. And she said that they focused on like too much in 7, 8, 9. Like they didn't really give any character like enough development for them to be like as interesting as they could have been. Like there were some characters they probably should have just killed off, but like it was just like too many characters they had to develop instead of like just like a few. Like what made 4, 5, 6 like way more magical, I think, is that like the whole crew was together, but like they all like developed well together. Like Luke was like kind of like a whiny farm boy when he started out, and then like by episode 6 he's like just like the wisest dude in the whole galaxy. Like Han Solo was like a bit of like a wild man in episode 4, but then by the end he was like a loyal dude that was like all for the Republic. So yeah, Leia too, they did a great job with. Like Leia, they didn't do her enough justice, that she was like supposed to be like this super strong Jedi also, but like they kind of like hinted at it in 7, 8, 9. So oh, your favorite is 6. Yeah, 6 is fun for sure. That's awesome. So worst movie of 2019, I think even Mark Hamill, Luke Skywalker, like the actor for Luke Skywalker, I think he like hated the movies too. So let's see. So is most of let's see here, making sure I'm on the right. Is high math built off vectors? I had no idea that we would be to learn about how to apply calculus to 3+ dimensions. My first units were parametric plotting. So yeah, with higher math, you're going to learn about vector valued functions. It's kind of a split, because high math is such a massive topic. Higher math, like you could be talking about like combinatorics, graph theory, which is like kind of a unique field. That's more like permutations, combinations, and whatnot. I mean, not that there's no way that it segues into like vectors and stuff, but there's different branches of higher math that will use vectors, and some of it doesn't use vectors. So, and math is like an ever-growing subject. Like number theory, like you don't need like a ton of vectors in a class like that. Because I've taken a bunch of math classes, so like I'm just basing this all off of memory now. But high math, like yeah, you're going to be working with vector valued functions. In linear algebra and advanced linear algebra, there's like tons of vectors. There's like the triangle inequality theorem. I don't know if you remember that from geometry. But in geometry, you learn about the triangle inequality theorem. There's like a vector version for linear algebra. So yeah, parametric plotting, that's one of the cooler things about Calculus 3 is like you learn about new coordinate systems. Like in Calc BC, you'll learn about polar coordinates and parametric. But in Calc 3, there's like, spherical coordinates. There's polar coordinates where you have, you have like two R values, like you're like going out one way and the other, and then like you rotate. But then there's also spherical where like you go out and then like you have two angles. You have like theta and like phi or something. So you rotate twice to get to your point. So it's pretty interesting stuff. Yeah, the beginning of Calc 3 is really just like, how do you do all this stuff? So I remember like Calc 3, there was also like, you have like an equation of a circle in geometry. There's like an equation of a sphere. So it's going to be like x minus h squared plus y minus k squared plus z minus lowercase l squared equals the radius squared. So, I mean, there's a lot of overlap. Like you learn about the Pythagorean theorem, but for like 3D. So it's like, like kind of like a lot of pieces like moving into it. But once again, Calc 3 for me was like 2009. So I'm definitely rusty. And I was telling everybody else that I plan on relearning it over the summer after the Regents, after June, I'm going to learn Calculus 3 in July and August is my plan. All right, more comments. What do we have here? So let's see. Yeah, they are going to go. Vectors are covered in Calc 3. So it's, Calc 3 sometimes is taken like kind of side by side with linear algebra, which is like way more vectors. But yeah. Oh, and let's see. Of course, he hated those movies. Yeah, sitting. Yeah, they really didn't do his character justice. And I feel like it was like a little bit out of character for like Luke to kind of just lose faith all of a sudden and be like this recluse, because he was like really like developed well into episode 6. And then all of a sudden he's like just like hiding out and staying away from everybody. So let's see here. The build up. Cool. Did I take partial differential equations? I did take that. So for, PDEs, I remember that's like, you need calculus 2 to be successful in ordinary differential equations, but partial differential equations, you need calculus 3. I did take that class. I got getting like a full A in that class. It was like very satisfying, but it was very technical. It's like very algorithmic, like just a lot of techniques to learn. Fourier series, I think, was like what we covered in that class. It was like some pretty interesting stuff. But once again, I'm very, 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 very rusty. But I mean, it was like really fun being a math major. Like it was painful, a lot of suffering. But I really do enjoy the classes that I took. Oh yeah, so defining speed with the dot product, because it kind of uses like that absolute value concept for sure. Yeah, Disney took over. I would say like The Mandalorian was like, I enjoyed The Mandalorian. I think it had like decent writing and stuff. So, Disney, in some ways, like it could be like they Disneyfied it, but in other ways, like Disney is like pretty decent at, making their storylines, because they have so much money, Disney, that they could just like hire, like their team of writers are just amazing. So that's something that stood out. All right, let's see. Does anybody have math questions? Let me just check this out real quick. Did anyone send... So any topics that people want to learn in the chat? I'm happy to just talk to people too. This is like very fun conversation. Oh, here we go. Lord of the Rings, new movie was okay. I did not see the new one. I've life with kids, it's like, I don't get to go to the movies a lot, but I remember seeing the old ones. By old ones, the ones from like the early 2000s, and like those were very, very intense. Those movies were really long too. So, but I did enjoy them. They were fun. It was I would say like if you read the books, then it's like maybe more enjoyable. Kind of like, I don't know if people are into like the Harry Potter series. I remember like the Harry Potter books, like being like a big part of like, my book collection growing up. Like Didn't get like super excited about reading as a when I was younger, like my teen years, but like I definitely read all of those, and I did read some other books. So, but Lord of the Rings for sure. Like, I mean, I enjoyed those movies; they were fun. Very long though. Like, you got to have like nothing going on that day if you're gonna watch Lord of the Rings. Lagrange multipliers, for sure. What did they use, like lambda for that or something? So, doing those right now. Ooh, okay. Calculus of variations. Now I'm gonna be honest. So at MG Pablo, that's the one class that I didn't take. It was called Real Analysis Part 2. I took Real Analysis Part 1. The only reason why I didn't take Real Analysis Part 2 was like I was running out of time, and I really, really, really wanted to take the class with this like one professor. My favorite professor, I went to SUNY Binghamton, was this guy. His name was Professor Zaslavsky. He's still working there, I think. And he had his PhD from MIT in combinatorics and graph theory. So I took combinatorics with the guy, and then I really wanted to take graph theory with him. So then I wasn't able to take Real Analysis Part 2. And at the end of Real Analysis Part 2, I believe that class, they introduced people to calculus of variations. And that is like, I think where math really starts to get fuzzy. Like, they kind of show you like how ridiculous it gets. And I think like in graduate level math is when you really like do a deeper dive into that subject. But that was probably one of the most ridiculous classes that I took, real analysis, because we had to do proofs behind the theorems of calculus. And I believe in Real Analysis 2, they did the proofs behind the theorems of Calculus 3. Like, you would prove why Green's theorem works. And Green's theorem is like one of the last things you learn in Calculus 3. So that's definitely like where things get wacky, for sure. So at Ricky, hello. Nice to have you on, Ricky. I'm glad you're here. Hope you're doing well. Let's see. Don't just solve for x not using the template. Oh, next term. Very nice. Very nice. All right, let's see. Green's function in calculus. Very cool. All right. So this is a nice little, community we got going here. I'm glad you're all like-minded individuals, and you're all like heading in the same direction here. So very, very nice. Let's see. Are there any math questions? Nothing just yet. All right. So we have, oh wow, yeah, all right. So we got up to 27, 28 viewers. Very, very cool. I'm glad we got decent turnout so far. And let me just keep monitoring this chat here. Anything else? I mean, I guess I could switch over and do some math problems here. If anyone has like general questions, by all means, let me just pop this back into the chat. Let's see. So let's see here. Top chat. All right. And, it's this button here, I believe. Restore the chat. Okay. So now I'm going to switch back to Good Notes, and I'm going to do some math problems here. But if anyone's got questions, like I said, I could really just... Oh, all right, wait, one more. Favorite movie of all time? That is a hard question. All right. That one, I could probably give you like a few, because it's really hard to pick one, because there's like so many genres to choose from. So comedy... Depends what kind of mood I'm in. Like silly comedy, I would say... I mean, Dumb and Dumber always makes me laugh, like really hard. It's ridiculous though. Tommy Boy, I like Chris Farley movies. But comedy-wise, I really like the movie The Big Lebowski. It's just like completely insane. It's like a movie that people are either going to really like or just be like, this isn't funny at all. But for some reason, The Big Lebowski I find to be like really funny. Action movies, I would say Terminator 2 is like the perfect action movie. And then if I had to pick a drama, I don't know. That one's tough. Maybe like one of the old mob movies are fun, like Goodfellas or something. TV shows, I would say Sopranos or Breaking Bad are my top two. But they're very intense shows. But I mean, I could rewatch those like numerous times for sure. All right, let's see. I could send parametric problems. All right, yeah, go ahead. We want to look at parametric for sure. We could do that. So at Marin Elise. So we'll take a look at those. I mean, I could type in some parametric stuff of my own as well, and then see how it pairs up. So waiting for this to load. Yes, I'm not doing a word search. This book is massive. Book gets upset. All right, 22 sections. So let's see. Find the equation of the tangent line at the given point. So tangent line's the parametric. And this is nice because this is Unit 9 in Calc BC, and I'm rusty. I haven't done Unit 9 questions since my last students. All right, so let's see. Equation of tangent line. And let's see, at the given point. All right, so we'll go through a few of these here. Now, let me just double check here. Let's see what. All right, so 57. All right, we got time. Okay, now let me see. I'm going to borrow a question. Let's see, x equals 2 cosine t. And we have y equals 2 sine of t. Now, with these here, and let's say we find the tangent line at t equals pi over 4. So when you're writing the equation of a line, what you need to know about your curve, this is not necessarily this. I'm just drawing something random. I'm going to pretend we don't have a calculator. But what we need to write the equation of a line is we need to know the slope. So we need to know the slope. And we need to know a point. Now the point is going to be from, let me make this a little neater. It's going to be like x of t, comma, y of t. So this one, like I would just say, all right, what's x of pi over 4? And that's 2 cosine pi over 4. And cosine of pi over 4 is square root 2 over 2. So this is just going to make square root 2. So that's like our x coordinate here. Now our y coordinate, let's do this in this color here, would be y equals 2 sine pi over 4, which is going to be the same thing, because sine pi over 4 is also square root 2 over 2, which is going to cancel this. So, oh, let me write this with better notation. So this is specifically at pi over 4. So I'll call this y of pi over 4. So we have y of pi over 4. And for this part, this is just going to equal square root 2. So our point, we'll write this out a little nicer. Our point is going to be square root 2, comma, square root 2. All right, this is not what the curve looks like, but it's going to give us a rough idea. This might actually be a circle. I want to say this is a circle. So I'm going to get to this in a moment. I believe it's a circle. Now, how I know it's a circle, let me extend this. So we'll add a page in here. Is that if we did x squared, so let me just write x squared is equal to 4 cosine squared. And y squared would be equal to 4 sine squared. Oh, okay, and then if you go like this, x squared plus y squared is going to be 4 times cosine squared t plus sine squared t. And sine squared plus cosine squared is 1. So this is really a circle centered at the origin with radius 2. So if I want to draw this nicer, I want to make this way nicer. I'm going to draw a circle. Okay, so this is actually a circle. And pi over 4 is 45 degrees. That puts us here. So this is the point root 2, comma, root 2. And the tangent line is going to go like this. Now, I know just by looking at this that the slope of the tangent line is going to be negative because it's a, it's on this part of the circle here. And the line is like a decreasing line. But now to find the derivative, because to find the slope, you have to find the derivative. But in parametric world, dy dx, the slope, is equal to dy dt over dx dt. So now we can find dy dx equals dy dt is 2 cosine t over dx dt is negative 2 sine t. And now these are going to cancel here, and we're going to have cosine over negative sine. That's negative cotangent of t, or I could just leave it like this. I don't have to write cotangent because in a moment we're going to plug in pi over 4, and maybe you don't have that memorized, but cotangent of pi over 4 is 1. So I mean, whatever. Maybe I will write that. All right, so we got that. Cotangent of t. So then if we want to find the slope, dy dx at t equals pi over 4 is going to be negative cosine pi over 4. I'm sorry, negative cotangent. Yeah, I've been going for really long today, so a little bit sleep deprived. All right, so this is going to be -1, which makes sense because if we look at this picture here, this is like at the 45-degree mark, the slope is going to be -1 here. So that's definitely looking good. So now the equation of our line, we're going to have y minus square root 2 equals -1 times x minus square root 2. Okay, and you can leave it like this. For AP calculus, you don't actually have to simplify. If you want to simplify, you have the option to. This is y minus root 2 equals -x plus square root 2. And then if you add square root 2 to both sides, you're going to have y equals -x plus 2 square root 2. Okay, so that would be our line. Now let me look here at the email. And what do they want you actually to do here? Oh, maybe if I zoom out. X equals 2 secant of t, y equals 4 tangent t. Yeah, so at Marinelli's, like what I would do for these questions is, let me pull up the calculator. So let me do this. And I'm going to, wait, let me fix this here. All right, so here, I'm going to move this over. So let me just see. So it stands out. Okay, so for now, it's not going to look amazing. Okay, so what I would do for something like this, I would clear this out and let's just see. Oh, did that get, oh, what just happened here? Oh, here we go. That's better. And I'll get a little bit out of the way here. Is if I want to graph parametric, I go to mode and I switch over to parametric. Now, the reason I recommend this is because a lot of the questions on the AP test, like they're going to, like half the test you get a calculator, and some of these parametric equations are kind of insane to graph without a calculator. So you switch over to parametric, you're in radians, and then let's say you had x equals -t squared over 3. So, you could write stuff in like this, and then you write your y is equal to t. And then when you graph this, like zoom 6, you can see what your graph looks like. And then if you were to pull up a table, you see here, like if you start at 0, you're at the point 0, 0. And then when t equals 3, you're at -3, 3. T equals 6, you're at -12, 6. So this gives it like a sense of motion, that you're starting at 0, 0, and then like you're heading like in the northwest direction here like this, okay, as time goes on. So that's what makes these questions like, sometimes tricky, as it's like, how is this different than just a regular graph? Is that like at each time, that's the parameter that, by giving it a parameter of time, it's going to give it like a sense of motion. Like, where am I at t equals 5? I would be at the point, and I might as well do that, second trace value t equals 5. You see it's going to place me here. Whereas if I was like, where am I at t equals 2? I'm like way back here at the beginning. So that's just something that jumps out at me when I, if I have to graph these questions. Now, if you wanted to find second trace number 2, you could find the derivative. Let's say you want to know the derivative at t equals 2. It's going to tell you. In that last example, we looked at, what was it? It was 2 cosine t, 2 sine t. So 2 cosine t, 2 sine t. What's nice about that one is, let's say I want to just use the calculator the whole way. I could hit second trace value, pi over 4. And you see how it gives us like the square root 2, square root 2. But then if I want to know the slope at pi over 4, it'll just tell me right away that the slope is -1. All right, so you don't actually have to know how to do this by hand for some, if you're in the calculator section, but finding the slope by hand is something like you'd probably have to do. And then sometimes removing the parameter is like part of it. So, that's just something sometimes you'll have to do, is going from one form to the other. It's just like a lot of algebra, just like a lot of substitution. So, just something to be mindful of with these questions. But they are, good questions. I do appreciate those. All right, let's see. Anybody? Let's see. Can you explain Taylor and Maclaurin series? Oh, okay. So at Marty, that's a fun topic to explain. Let me think back to my old lessons. All right. So hopefully the way I explain it will do it justice and make it simpler. So what is a Maclaurin series? Okay. All right. I'm going to try to make it as simple as possible because once again, at Marty, like when I learned calculus in college, like it wasn't like taught in like a super conceptual way. They kind of just like blasted through a lot of questions. So it's kind of tricky. So something like sine of x. If I write the Maclaurin series for sine of x. Now, I haven't taught this also in a long time. Like I'm teaching this year, but I'm definitely a little bit rusty on this one too. But I believe it's -1 to the n, and then it's odd, so it's going to be x to the 2m plus 1 over 2m plus 1 factorial. I believe this is the Maclaurin series. Okay, but like what on earth does this even mean? It's a little tricky. Like what is a Maclaurin series? Now, the formula, this is something you absolutely need to have. For a Maclaurin series, the formula starts at n equals 0 going to infinity. And it's the nth derivative at 0 times x to the n over n factorial. Okay? So, Marty, the first thing I guess I'll talk about is why, what are these things to begin with? So let's say sine of x. If we look at sine of x is in purple. It's going to go like this. Okay, so there's sine of x. Just continuing on and on forever. But if I start to expand this, let's say I take sine of x, and if I plug in 0, I have, this is my thought process. If I plug in 0, I'm going to have -1. So n equals 0, I have -1 to the 0, x to the first, over, and I have 0 plus 1, or 1 factorial. So this is equal to x. So it's going to start off as x, and then it's going to go minus x to the third, over 3 factorial, plus x to the fifth, over 5 factorial. So a Maclaurin series is centered at 0. What that means is that we're starting with one point that matches sine of x, and that's going to be at x equals 0. And then I'm going to borrow the calculator for this, because if you really want to understand what this is, I believe I have a video on this too. So what I will do to self promote, I don't know if you've watched this video yet, but let me just write Maclaurin series Vin teaches math. And let me just see. Deriving the formula. What is a Taylor polynomial? I believe this was the video. Let me just see here. Yes, this is the one. So this is for, Marty, but anyone is welcome to watch this. I'm going to throw this in the chat. That if you want to know what is a Maclaurin series, I really took my time to design that video. So if I basically reteach that video, it's gonna you'll get it, but it's not gonna be as smooth as when I edited it and I cut out all the stuff. Okay, but basically if I were to take just one piece of this, y equals x. All right, if I said sine of x is roughly equal to x, you see it's just the line y equals x. And when we're close to the center, 0, you see how that line that line is like fairly close to the curve. But then as we move away from the center, the curve like clearly separates. But then what happens is as you add more terms, like this, if you were to graph x minus x to the third over 3 factorial, it's going to get even closer. So yeah, let me get rid of this first. If I were to graph this much, it's going to get even closer to the curve. Like it might do like, I don't know, like something like kind of like this, but it's going to get even closer. It's going to start to like bend a bit. But then if I were to add in even more, let's say I add in the next term plus x to the fifth over 5 factorial. It might follow it like, you know, like up to like this certain point here and then do all sorts of stuff after. So the concept of a Maclaurin series is that it's centered at 0, and that's a point that it matches up with the function. And then like the polynomial is like born out of the center. And as you add more terms, the polynomial gets closer and closer to the function. But the concept is that we have infinite terms in our polynomial. So this, like in words, tells you sine of x, well, I'm going to say is, like can be represented as an infinite polynomial and I'll just say with all odd powers, because sine is an odd function. So it's like x to the first, it has an x to the third, 5, 7, 9, and so on. So this is kind of the idea. Now, if you're wondering like, how do you build this? This is the formula. All right. I also have a video on deriving this formula, like showing where this comes from. But what I'll do with this, so let me borrow this formula. And I'll show you how to build sine of x. So let's take this with us. We're going to need a new page. So let's see. All right. So we have, sorry, I had the hiccups. I had too many snacks before this. Yeah, I bought these chocolate chip cookies for my kids. And like that's the dangerous part. Like, you know, my kids' snacks are like delicious. So then I wind up like eating a lot of them. So I got to stop doing that though. It's like just not good. I should buy carrots or something. But chocolate chip cookies are so much nicer than carrots, if we're honest. All right, so this. Let's say I want the Maclaurin series for sine of x. So that's like a standard like thing you'll learn is like, all right, if f of x is equal to sine x, what you do is you keep finding derivatives until you notice a pattern. Okay, so we have this, and then, you know, we get to the third derivative and we might be getting frustrated, but then something nice happens. When you find the fourth derivative, it loops back to sine of x. Okay, now if we expand this formula, I always would tell my calc students, practice expanding this, that this is, if you plug in 0, that's like the 0 derivative, which is just the function. So this is f of 0. X to the 0 over 0 factorial is just 1. So I have f of 0, and then I'd have plus f prime of 0, x to the first over 1 factorial, plus the second derivative at 0, x to the second over 2 factorial. And let's make some space here. Yeah, these questions are like marathons, and that's not going to help us. Let me do this. All right, so I'll go here like this. And if I continue this, plus the third derivative at 0, x to the third over 3 factorial, this is like the expansion of the formula from n equals 0 to infinity. Like I would just keep going, but I'm not going to go past 3. So then what we do is we actually plug in 0 to all of these. We say, all right, f of 0, sine of 0 equals 0. And let's change colors here so this doesn't collide. So I have f of 0 is equal to 0. F prime of 0, I say, what's cosine of 0? That's 1. F double prime of 0 is 0. F triple prime of 0 is negative 1. So the pattern is 0, 1, 0, negative 1. 0, 1, 0, negative 1. So now that we have this, we could substitute. Our function is sine of x. and this is equal to, I have f of 0 is 0, plus f prime of 0 is 1, so I have 1 x to the first over 1 factorial. Then I have plus the second derivative at 0 is 0, and then I have x to the second over 2 factorial. But these terms here are going to cancel out because they're being multiplied by 0. And then we should start to see the pattern after this. It's 0, 1, 0, negative 1. So I have minus 1 times x to the third over 3 factorial. But remember, the pattern is 0, 1, 0, negative 1. We use the negative 1, so the next number is going to be 0, and it's going to be x to the 4 over 4 factorial. And then we're going to go back to plus 1 times x to the fifth over 5 factorial. And then minus, this is going to go on, but the thing to notice here is that all the even terms are canceling out. So then we write even more. We simplify this more. This is sine x equals. This is just going to make x. And this is going to make minus x to the third over 3 factorial. Then we're going to have the next non-zero term is plus x to the 5 over 5 factorial. You may start to see the pattern. See, it's like 3, 5, 7 over 7 factorial, but it's plus, minus. And this pattern continues. Okay, so you get here, and then the challenge at this part, this takes time, is writing this as a series. Okay, so we're going to go series from n equals 0 to infinity. It's a power series because it has an x in it. Okay, just remember, easy way to remember, a power series has an x. Okay, and like a standard series is just in terms of n. It wouldn't have the x attached. So just, that's something to be on the lookout for. So this thing, my commentary here is that this alternates. This is an alternating series. So that means it's going to need a negative 1 to the n. And I'm starting at n, not n plus 1, because negative 1 to the 0 is positive 1, which matches the first coefficient. And then we're going to have x, but be careful. We're not going to say n here, because we would have like x to the 0, x to the first, x to the second, where these are only odd. So the next thing I think about is that odd, you're going to go with like 2n plus 1. Even, you would go with 2n, like this. So here, I'm going to call this x to the 2n plus 1, and you could even do a mental check here. If you plug in 0, x to the 2 times 0 plus 1 would make x to the first. And then the factorial matches the exponent. So this is going to be 2n plus 1 factorial. And there it is. That's the Maclaurin series for sine of x. So I hope that helps. What makes it doable is really understand this formula. I would say know this formula, but learn, let me make that neater, learn to expand this formula. Okay, if you learn to expand this formula, like we did here, like that's like what just happened here, that's what makes these questions possible. So you expand, find the coefficients. So that's like the steps. I would say expand, then you find coefficients, you plug in, and then look for the pattern. Okay? And once you find the pattern, write as a power series, which I'll abbreviate. Okay, power series. Okay, so write it as a power series. That's what you want to do for something like that. Okay, cool. Other questions here? Concerns? Let's see. Who else do we have? So we have just a few people now. I think, yeah, it is getting late. So I just passed the 1 hour mark. So I'll wait for any other commentary. Do we have any other questions here? Or see how we're feeling about this? All right. So then what I will say, because we did pass the 1 hour mark, if there are no more questions, just going to say thank you to everybody who stopped by. All right. I will be on next week for sure. Unless something comes up, which then I would announce it to the community here. I'm always at the mercy of my 2 kids. Oh, yes. My email is you see right above the whiteboard. It says email vinteachesmath@gmail.com. Okay? And you could send in a question. If it's something like Calc 3 and up, I'm not going to be able to help. So I'm not sure, MG Pablo, if that was you, like talking about all the super high level stuff you're taking. Over the summer, my goal is to live stream me relearning Calculus 3. So it'll be fun because I'm going to make mistakes and I'm going to like work through them and troubleshoot. But I'm good up to Calculus 2, but when the school year is over and I have nothing to do in the summer, I'm going to live stream me relearning Calculus 3. All right, so yeah. But I mean, send it anyway. It'd be interesting to look at. Maybe if I can't answer it now, I'll answer it for the next generation in like July or August. Yeah. No, I know, but 2009 is a long time. You would be surprised if you don't do Calculus 3 for like 14 years, 13 years. It's going to go right out. You got to use it for it to stay fresh. I think down the line it'd be fun to teach at a college. I taught at a college for a year, and I mean, I don't know if they would give me Calculus 3 though, like if I'm not a professor. I don't know how that works, but they had me teach calculus at one point, so that was cool. But we'll see. Oh, what do you think of my comment above, though, about Green's theorem? Let me scroll up again. Let me see. All right, now I'm doing those right now. Blah blah blah. Is it the same as the calculus of variation since we are using a function to maximize each other? Oh, it's something called Green's functions and calculus. That's very interesting. Oh, wait, that was clumpy. I'm sorry. I'm like mixing up. Yeah, I need a. Yeah, maybe I'm missing. There's parametric plotting. I mean, I would. Oh, it's below that. I mean, just Green's theorem in general. I mean, I think it had something to do with line integrals. It was like very dense, but to be honest, like any math that I learned in college, like if I could give any words of wisdom or encouragement, it was really just a matter of sitting at a table and figuring it out. So at MG Pablo, I don't know if you have like a study group, but I remember like my old crew when I went to Binghamton, I had some like really smart people in my group. Like they were just wow. They were like, some of them were like really, really, really smart. And, learning it with them was nice because for one, it like forced me to be on my A game, because if you're studying with like these really like high level people, like you don't want to show up like unprepared or work with them and just kind of leech. Like you want to like be a contributor. So it definitely forced me to move. And that was definitely something that I'll always remember, is the crew that I went with. So, I mean, I would say, if you're already in a class like that, then, let me see here. I'm still got that part frozen. Let me just, there we go. I'll get that out. So if you're, taking a class like that, by now, if you don't have the confidence, like if you don't feel like super, super, super confident, I would say, you know what, like, do your best to get to that point where you are confident that you could learn anything in the college, at like the college level, like, any college level math you could learn. It's just like, I don't know, it hits a certain point where you're just like, all right, I just know what it takes to learn something and I'm willing to do it. Like, don't get me wrong, math eventually then gets to a point where nobody could do it. There's like the Riemann hypothesis that like the smartest mathematicians in the world still haven't, cracked that one, but it's, what's it called? Like for the university level math, it's like definitely something you could just persevere through and figure out. But the group that you form is, like, for me at least, was like really just so helpful. I don't think I would have completed my math major if I didn't make like the right friends, because like you kind of help and you carry each other. Like if someone's like not really like feeling it and they're like down, like it's the community that it gets each other through, So that's what I remember the most. That's what I valued the most, and like probably ultimately why I became a teacher is like it was fun to be the one teaching the group, but also like I could remember many occasions where I was the one like, all right, could you help me with this? Could you teach me this? Like maybe I missed class because I had some stuff going on, and like just having the smart friends that were willing to sit with me and like help me through when I was struggling. Like I'll never forget that. That's like something like pretty special. And like for my current AP classes, that's what I'm trying to recreate is, that vibe of everybody helping each other. Oh, okay, so Green's theorem is, your last unit, 3D flow along. Yeah, no, definitely like in Calc 3. That's I have my old textbook. I, brought this with me. I have this here. If I go, let me see. I'll check that email for sure. Let me just see. Green's theorem. Yeah, Green's theorem is like unit 17. That's the last one. Page 10,091. Let's see here. Oh, that's an interesting little formula here. Green's theorem. The piecewise smooth, simple closed curve in the plane, and let D be the region bounded by C. Okay, and P and Q. Oh wow, yeah, this is like I can't believe I used to know how to do this. Like I have to really just get smart again and get back into it. But let me check that email. So, let's see here. The email go through. Oh, there it is. All right, let's see. In which direction should you leave the point to get the greatest increase of x, blah, 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 blah. Yeah, this is like pretty interesting stuff. I'm out of practice, Marvin G, but that's something that, like I said, I want to for sure get back into. What grade level are you in? Are you like, I maybe missed that in the very beginning. What grade level are you currently in that you're learning this? That's like pretty interesting. Because I know some high schools do multivariable calculus. Oh, main issue in that email is explaining what the 3D contour plot means with the tangent vector perpendicular to it. Explaining what the 3D contour plot. High school senior, wow. That's so awesome. That's like an inspiration for like, I know, some 16 turning 17. Very nice. So you're advanced. Good for you. You're on your way. Let's see. In which direction should you leave the point to get the greatest? Yeah, I would, Marvin, I'd have to like get back into multivariable calculus for sure. It's something that I'm definitely out of practice with. But I you know what? I was streaming chess and I had randomly like my first person to ever check in was there was a freshman who took it. Yeah. Hang on a second. I'll tell you another cool story. I gotta give this guy a shout out. One of my professors at Binghamton had a son that was a math prodigy. And when the guy was like, he was like 13 or 14 years old, he was taking graduate level math at Binghamton. If you want to look up someone's, he's like a really interesting dude. The guy was a, what's it called? A Putnam Fellow. Like he's like super, super high level for sure. But the contour plot, let's see. Oh, all right. I see that's a nice picture. So now, in which directions should you leave the point to get the greatest possible increase of the function? Does not represent. Explain what it is and include it in your solution. Yeah, that one, let me just read your issue. what a 3D contour plot means and with the tangent vector perpendicular to it. I mean, all I remember, I don't know if this is going to help much, but when you're talking about like a tangent vector being perpendicular to a plot, I just remember like my one of my college people telling me like perpendicular in space is like it's like coming straight at it like this. So it would have something to do with, if you're talking about like the tangent vector perpendicular to the contour plot, it's like it's coming like straight at it in this direction here. Like it's just like sometimes something as simple as using the like basic definitions is like the key. But I know it would have something to do with like probably finding the derivative at the surface and then like finding like the like kind of like that negative reciprocal concept is something that would come into play here. But like I said, I'm very rusty on 3D, geometry and like, 3D calculus. So yeah, 2009, 13 years ago. That's the last time I did calculus 3. But very interesting stuff. The gradient points in the direction of the greatest increase on the surface. Yeah, and the gradient, was that the perpendicular? Let me just see. So gradient vector points in the direction of the greatest increase of a function. Yeah, I would have to like get all those old formulas back and stuff. It's cool though. It's like it's like kind of like a flashback. It's bringing me back and stuff. But let's see. I don't understand how to explain what it means for 4D because my teacher only says, yeah, yikes. Oh, cool. So you could definitely be like helping each other and stuff. Like it's cool, yeah, if I let the community take over and talk about it. Not as many what's it called? There's a few. If we got at least one other person taking Calc 3, that's cool, for sure. All right, but it is 9:30. I am gonna check out. I really appreciate the people coming by to support this. Like it's so cool. Like just making this a space where people could talk about math and whatnot, or just random questions. We didn't get a super like ton of calculus questions today, like for calculus 1 and 2, but that's all right. But I do want to add in, all right, MG, Pablo, Clumpy, you are all inspiring me to learn multivariable calculus because I think it'd be really cool one day to be able to add it to my own high school. But I don't know. It's like a little ways away for sure. But thank you all for stopping by. I'm going to check out, and I'll see you all next week if you are available. Thank you.